The curse of dimensionality is a well-known problem in the field of machine learning and data analysis. It arises when working with high-dimensional data, where the number of features or dimensions of the data is very large. This can cause problems in various machine learning and data analysis tasks, such as classification, clustering, and feature selection. One of the main reasons for the curse of dimensionality is that as the number of dimensions increases, the amount of data required to accurately model the data also increases. This is because, in high-dimensional space, the data points tend to be spread out, making it difficult to find patterns or relationships between them. With an increase in dimensionality, the volume of the space increases exponentially, and this leads to a sparsity of data points. This sparsity of data points makes it difficult to get an accurate representation of the underlying distribution of data and can lead to overfitting or underfitting of the model. Another reason for the curse of dimensionality is that many machine learning algorithms are not designed to work well with high-dimensional data. For example, many algorithms rely on distance metrics, such as Euclidean distance, which can become less meaningful in high-dimensional space. In high-dimensional space, the distance between 2 points may not be a good indicator of their similarity, as the distances between all points tend to increase with the dimensionality of the space. To mitigate the problem of the curse of dimensionality, several solutions have been proposed. One of the most common solutions is dimensionality reduction, which involves reducing the number of features or dimensions in the data. This can be done through techniques such as principal component analysis, PCA, linear discriminant analysis, LIDA, or singular value decomposition, SVD. These techniques convert the data from a high-dimensional space to a lower-dimensional space, where the data points tend to be more concentrated and patterns or relationships between them are easier to find. Another solution is to use algorithms that are specifically designed to work well with high-dimensional data. These algorithms, such as random forests or neural networks, can handle large numbers of features and are able to find patterns or relationships in the data that would be difficult to detect with traditional algorithms. Random forests and neural networks, for example, are able to detect complex nonlinear relationships in the data and can work well in high-dimensional space. Another popular solution is to use regularization techniques like L1, L2 regularization, which helps to minimize the model complexity and prevent overfitting. It is also important to consider the nature of the data when dealing with the curse of dimensionality. For example, if the data is highly correlated, it might be possible to use feature selection methods to select a subset of the most informative features. Ultimately, the best approach will depend on the specific problem and the nature of the data. It is important to explore different solutions and evaluate their effectiveness on the specific task at hand. In practice, a combination of various techniques can be used to mitigate the curse of dimensionality. And with the help of this combination, we can achieve better performance and generalization capability of the model.